Hello guys, welcome to my channel. So today we are going to do another problem from GeeksForGeeks, and this problem has been asked by a lot of companies. So today we are going to work on remove loop in linked list, and this is the problem statement, and you can also see the tags, and these are the companies which have asked these questions. But it's not like not other companies are asking this question too. Because I have seen this question a lot in other companies also, which could be Times Internet or maybe your TCS, right? So any company, but you have to prepare yourself for the worst. So let's see what it says. So we have been given a linked list, and we have been provided with x equals to 0, meaning if there is a loop then it will be 1. It won't be 0 actually, and if it is 0, that means that there is no loop. If it is any value other than 0, it means that at this point, at this node, there is a loop from the last node. So when x equals to 2, which means that at the second node, the last node is coming back. Okay, so you can see here also a loop here means that the last node of the linked list is connected to the node at position x, and position starts from 1, and that's why this is a loop. So how should we solve it? So logic is pretty simple, which I did also in the last video, detect loop. So we will have to create two pointers, slow and fast, and initially both of these pointers will be pointing to the head, which means that the first node. Then we will move the slow pointer one node at a time and the fast pointer two nodes at a time. Okay, at a point, slow pointer and fast pointer are going to meet. So when they meet, there is a loop. If they don't meet, then there is no loop, right? So here what we need to do is, when we see that there is a loop, now we have to remove that loop. So what we will do is, after checking there is a loop, we will move our slow pointer back to head, keeping the fast pointer at its own location. Then we will move two pointers one node at a time. So slow pointer is also moving one node at a time, and the fast pointer is also moving one node at a time till their next. That means that slow dot next is equals to fast dot next. Till that happens, we are going to move them one node at a time. When that happens, when the slow dot next is equals to fast dot next, that means that we have met at the point where we have to remove the loop. Then we will just make the next of fast as null. So this is really a theoretical explanation. Now let's see the diagram. So consider this as a linked list where we have a loop, and our slow pointer is here and fast pointer is here, which means we have initialized both these pointers to head. So now we are going to move slow pointer one node at a time, fast pointer as two nodes at a time. So in the first iteration, slow pointer is coming to this one and fast one is going to jump two nodes. In the second iteration, they are going to meet, because fast was here, it jumped one node here and the second node here. So fast is going to be here, but the slow pointer moved from 3 to 4. Now they met, which means that there is a loop. Now what we have to do is, we have to move our slow pointer back to the head and keeping fast pointer here, right? Now what we will do is, we will keep moving slow pointer and fast pointer one node at a time till slow dot next is equals to fast dot next, which is going to happen in the first iteration itself. So if you see, slow is here, fast is here, and slow dot next is 3, fast dot next is 3. That means that the condition got satisfied. In this case what we have to do, we just have to make fast dot next, we just have to delete this and make it null. So ultimately it is going to be look like this. So this is what we have to do, right? So let's write down this logic and let's see how it worked out. So what we have to do, first we have to we have to find out if there is a loop or not. So just to do that, I'm going to create 2 pointers. One will be slow, which is going to be initialized as head, and initially they both will be initialized to head. So node slow, node fast equals to head. Now I'm just going to create a condition which is to check if there is a loop or not. If there is no loop, then the pointers are going to be iterated at null. So when there is a null, we don't want to iterate anymore, right? So this is that condition where we are just checking if there is no loop, then don't execute this while loop. Now I'm going to iterate my slow node one node at a time and fast node two node at a time. So dot next. They are going to meet at some time or at some node. So slow equals fast. If that's true, what we need to do is we just have to tell, okay, we found a loop. Is loop found equals to true, right? Then we can break out of this loop. Okay, now I'll just create a boolean here. Is loop found, initialize it as false. Okay, now what we will do, I'm going to initialize my pointer 1, which is slow, and it is going to be pointing out to head, right? My pointer 2 being fast is again going to be fast. I'm just creating 2 more pointers to avoid any kind of confusion, right? So my pointer 1, which is slow, and pointer 2, which is fast, but slow is pointing to head, as we demonstrated in the example here. So we moved slow here to the head, and that's what we did, right? Now what we need to do is we need to iterate another while loop till slow dot next not equals to fast dot next, right? In this case, we are just going to iterate slow as well as fast one node at a time. But there is no slow, there is no fast. So what we will do is we will just replace these values, pointer 1, pointer 2, same we will do here, right? Pointer 1, pointer 2. Now what we need to do, when this condition gets satisfied, what we need to do is we just need to do fast dot next. That means pointer 2 dot next equals to null. That's it, what we have to do. But we want to execute this loop, this thing, only when we encounter that is loop found is true. In that case only, right? So let's try to run this code. So as you can see, it is working fine. That's why output is 1, otherwise it would be 0. But it's not going to work in one input case, which as you can see is here. Let me simplify this to 1, 3, 4. So expected output is here 1, but my output is going to be 0. And this error, no such element exception. Okay, my mistake, to make it 3 actually. Right, so why it is failing, let's talk about this. So this scenario is going to always fail in only one condition, when the loop is coming back to the head. So let's see. So now let's consider this example, 1 2 3 4 5, and this one is coming back to 1, right? So when we iterate a slow pointer and fast pointer, it is going to come back, like when they are going to meet is going to be at node 1. So we can do the iteration one more time, but I think that won't be needed. So one node will be moved, so S will be here, fast will be here. Another one will be fast will be at 5 and slow will be 3. Next one will be slow 4 and fast move 2 nodes, so it will be at 2. Then it is going to be at 4 and 5, and the next iteration they both are going to meet at 1. Now what is happening is, this condition that we wrote, this is going to fail, because this while next, this condition should always comes when our slow is not equals to fast, right? When they are equals to fast, then we don't have to move our slow, we just have to move our fast. So in that case, what we will do is, we will keep our slow pointer there, but we will move our fast pointer. So we will move our fast pointer one node at a time till, so the condition is that, let me come down to the logic. So this is the logic, no, not this one. So we have to move our fast node one node at a time till its next node is slow pointer. So now we don't have to do slow dot next equals fast dot next. We have to do fast dot next equals slow. That's it. So now we are moving our fast node one node at a time, right? So fast is going to come at 2, then at 3, then at 4, then at 5. Now if you see, fast dot next is slow. So in this case, we are going to terminate this and just point it out as null. So let me complete this logic now. So what we need to do is, we need to this while condition, and this if there is going to be a if here, and there is going to be a else here. So here we will just do if pointer 1 not equals to pointer 2. Let me give proper spaces here. Okay, else what we will do is, we will create another while loop, and we will do what, fast dot next pointer 2 dot next not equals to slow pointer 1. If that's not the case, then pointer 2 is pointer 2 dot next. When that happens, which means that when we come out the while loop, we just have to do fast dot next being pointer 2 dot next equals to null. That's it. And I think I'm confusing you guys with pointer 1 pointer 2, so you can directly do this, slow equals to head, leaving out this fast. So let's run this code now for the test case, right? Okay, oops. So as you can see, output is 1. So this, if you try to submit this code, it worked, right? Now if this logic is bit complex for you guys, I'll give you another one. What I will do is, I will use set, because set contains unique elements, and Depending on that, I can easily check if there is a loop, the element is going to be get repeated. So if it is getting repeated, then I know that there is a loop first of all, and then I will keep node of a previous you can say previous node. So in that case, I will just point that previous node to null. That's it, right? So let me just create two nodes here, node previous, and then I will use one other node to iterate over. So I'll just name it current, and this will be pointing to head initially. Now I'm going to iterate over my current till it reaches null. Right now I'll check if my set is containing this element. If not, then I have to add it. I have to do current here. If not, then what do I have to do? I just have to add it, right? After adding, I just have to do current equals to current dot next. But before we do that, I have to make note of my previous one also, right? All good till now? Now trick lies here. When we say there is a pointer, there is a node which is coming twice. That means that before that node is being added, there is a previous counter pointer. So we will just do previous dot next equals to null. In that case, what do we have to do? We just have to return or break, whatever you want to do, and you don't need else. Right? So let's try to run this code. So one test case successful. Now let's see. Okay, sounds good. So this is one other logic. You may find like many other approaches, logics, but these are the two that I found that could be easy enough and easier to understand. So this is all about this video. I hope you have learned something new. And before we end this video, if you are new to my channel, if you haven't subscribed to my channel yet, please do. Have a good day, stay safe, and bye bye.